star. So you know why people stuck with this problem, because they were following my suggestion. That's like the upsetting part. I just realized that you start taking derivatives, and it's like product rule over here, lots of chain rule happening. Yeah, that's too much complicated. It will be still correct, but it will take you 3 times more time than it's supposed to. Solution. The idea is to use known Maclaurin series, if possible, and possible. And we do have known Maclaurin series for e to the x. E to the x has a series. And it's very simple to memorize, so I was impressed, I still remember it. 1 plus, and I forgot, x over 2, 1 factor, no, wait. I just remembered in my office hours. 1 plus what? X to the 1 over 1 factorial. Okay, I got it. Over 2 factorial. Over 3 factorial. And so on. Yeah, that's the simple one to memorize. Which has a series, x to the n factorial from 0 to infinity. Good. Totally like zoned out for a second.
Are those equations going to be provided on the test?
Very good question. We used not to provide them, and then I became coordinator, and now we do. These are provided, and we're either going to ask you to use these from the table, or we're going to ask you to create it from scratch using derivatives in the table I just showed you before. Like you create the whole derivative table. So both will be on the test. Right now, let's use this one. We already know it, so let's use it for only exponential function part, which is this part. This will be series. Let's leave the x7, x squared to chill for some time. So then, and this is where the previous chapter comes in, e to the, what is it, 9 minus 9x will be, that's your new input. Remember I always say, everywhere you see x, now plug minus 9x. That is the idea. So it's going to be 1 plus minus 9x over 1 factorial is 1 factorial. Let's not write it down. Minus 9 over x plus minus 9, not over, minus 9x squared over 2 factorial plus minus 9x cubed over 3 factorial, which is 6, plus, and keep going. Let's see how many do they want? They want us to go to x to the 5. Okay, fine. X to the 5 for some reason. Okay, that's kind of annoying. Minus 9x to the 4 over 4 factorial plus minus 9x to the 5 over 5 factorial, and let's keep going forever. Now we're gonna plug this. Oh no, they did not need so many. I realized why we have x to the 5, because we're multiplying by x squared. Only 4 are good enough for this problem. So these 4 plus dot dot dot, we're gonna plug into a product. What product, you can ask me? This product. So f of x is 7x squared, which was standing there and waiting patiently, times e to the minus 9x. E to the minus 9x equals, have enough space, 7x squared times 1 minus 9x plus minus 9x squared over 2. 2 factorial is 2 plus minus 9x cubed over 3 factorial, which is 6. Plus, and keep going, it's an infinite polynomial. And now we're going to be distributing into infinite polynomial. And this is something actually we never done before, so in such a cool manner. You did it before with sums, but can you imagine we can infinitely differentiate, infinitely integrate, or infinitely distribute? That is actually a pretty awesome idea. Distribute, 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 distribute. And this is how you get an infinite series for a function you actually need, which is a product of 2 functions, a polynomial and exponential. 3 factorial, 6, thank you, yeah. Erase this 6 factorial, thank you. Nice, good job for paying attention. 7x squared times 1 is 7x squared minus 7 and 9. Same you 9, she said 3. I had to do it in my language. X cubed. Somehow, like, the moment you learn the multiplication table in your language, it's almost impossible to switch to other language. So most of us do it in our language, I noticed. Plus 9 times 9 is 81. And let me just write down. 7 times 81. X to 4, right? Over 2, correct? But negative squared is positive. Thank you for checking. Minus, now it will be minus. I can see it's alternating. Plus, minus, plus, minus. And then it's going to be 7 times 9 cubed. So maybe 81 was not a good idea. 9 squared. 9 cubed over 6. X cubed times x squared is x to the 5. So see, the most interesting part is how the powers are changing. Every power is raised by 2. See? Plus infinitely many. They want you to either this is the answer. If they ask you for the series, this is the series. This is actually Maclaurin series since the center was 0. And we used known Maclaurin series. But they ask you for coefficients. Okay, fine. The coefficients will be c sub 0, c sub 1, c sub 2. They want to up until the 5th power. The thing is, whatever you see in front of you is not c sub 0, c sub 1, c sub 2. The formula starts with the isolated number. Don't you remember? This one is isolated number, or the original formula for the Taylor and Maclaurin series. This is rainbow box. We have isolated number multiplied by x to the 0, and then x to the 1, right? So if you don't see them, what do? Put 0. In general, in this case, we're starting with x squared. This should be x to the 0, x to the 1, x to the 2, x to the 3, x to the 4, like so. But we need coefficients. So coefficients will be 7 goes only to c sub 2. See? Minus 63 goes to x, goes so, like so. Goes to c sub 3. Nice. Then it's going to be 7 times 81 over 2. 7 times 9 squared over 2. 0, 0, because we skip them. And then they somehow keep going in your homework. So just keep at the other ones. More, so let me sign them. C sub 2, because they attach to x squared. It should match. 2, 2 should match with 3, 3. Should match with 4, 4, c sub 4 and x to the 4. Should match c sub 5. It's very nice in computer science that you just tell the dummy variable to count with the same counter. And that's how you answer your homework problems. If they ask you to x to the 5, then you keep going to the x to the 5. Oh. Good job, people. Be safe, don't get sick. So one more is missing. Let me write it down. C minus 7, 9 cubed over 6.
Quick question, just wondering if I'm doing this right.
Just a second, let me finish this. X to the 5.
Actually, I don't have a